Hi there, Sanjay Gangal. I'm here with Alain-Sam Cohen, Head of Product at DeepPCB. Hello, Alain-Sam.
Hi Sanjay, how are you?
Doing fine. So last year we talked about DeepPCB, but remind our viewers what DeepPCB is all about.
Yeah, it's an AI place and route tool that is web-based. So if you're working on PCB design and you're trying to design boards, if you're doing layout, you can use DPCB to either place and or route your board in the web app or via an API.
Okay. And last year when we talked, you had the routing part covered, but now you expanded the tool to cover AI-based AI-driven placement as well.
Yes, exactly. In PCB design, if you're doing layout and you have a board, you're probably going to try to place it first, have the components, and then do the routing. So you're going to draw the
Mhm.
traces. Thing is, we did it the other way around. We tackled the routing first. We got to a product that was mature, and then in parallel, a bit later, we started doing the placement. Now we have both the routing and the placement, which means that the loop is being closed, and you can even go from one to the other. So you can do some placement, do a bit of routing, replace a few components, go back to routing, etc. So you have a nice interactive and iterative loop.
And is it automated or is it interactive placement and routing?
So technically, it's fully automated,
Mhm.
but we have the option to make it interactive for designers who want to be closer to their designs.
Okay. And do you integrate with any of the existing design flows?
Yes, we integrate with pretty much anything. So we're natively compatible with Zuken, Altium, all the Cadence, Spectra, DSN file formats. What else we have? I think we have Eagle. Pretty much anything. So if you're working on your project within, let's say, Altium, you can always export, for instance, the PCB doc, send it to DPCB, get the place and route happen, and then kick it back to your tool of preference for like continuing the work, I guess.
Okay. And now with Deep PCB now being available as an API, how are customers integrating it into their existing EDA workflows?
Yeah, so it's even more integrated right now because now you have an API. So you go to DPCB, get your API key, and then you go back to your laptop command line, have a script, call DeepPCB, and then you will see, obviously, the file is going to be changed, etc. And then you're going to see from your IDE of preference, basically whatever you want, the board being updated. So if you call a routing through the API, you're going to see the routings, but you're going to stay inside your tool. You don't have to go out. You don't have to go to your Chrome or Safari web browser. You just stay inside your tool. DPCB is going to route and place your board, it's going to change it. And obviously, we can work together with people to kind of like have the options to stop, only route a few wires, only place a few components, etc. So this is why it's interactive. It's automated because you can just click and wait, and it's now integrated in your workflow. It's something which is pretty new. I think we released the API a month or two ago.
I see. And are there any specific use cases where this API capability has significantly improved time to market or design quality?
Yeah, we have a pretty convincing baseline. So one of our enterprise customers is working with boards that have, let's say, 2,000 error connections. So you can think about maybe a few thousand components, very, very low digit few thousand components, right? And for them, placing and routing a board usually takes a few weeks. And it turns out that with DPCB, they were able to route a specific board and place it before in, I believe, 22 hours, something like that, of work while they were doing
Mhm.
something else. And then they just took it over, kind of like made a few maybe finishing touches, and then they had something that was ready for production and manufacturing.
Okay. And you also mentioned that your platform has become more agentic. What does that mean?
So the first step towards being more, so first of all, like the baseline is that DPCB is agentic by nature because we're using reinforcement learning. Reinforcement learning is a system where you have an agent that works in an environment and is going to learn by trial and error. So you have the first agentic kind of like component. Now you're making it interactive. So you can say, okay, I want to this, and that. I want to fix this. I want to route or place. And then next step, you're going to have maybe an assistant or something like that that will help you understand your board and be able to specifically tell you what you should route, what you should leave for later, how you should do things, etc. And there's going to be some kind of interactivity with the AI models.
Okay. And you have demonstrated your products at Hardware Pioneers Max, PCB East, and now you'll be at DAC and PCB West as well.
Yes, that's correct. I think we're aiming to be at all the main conferences. The product is very mature now. It's useful. It's usable by enterprise customers. We already have very good feedback. So we're at Hardware Pioneers and PCB West and PCB East. Most of the feedback was that people thought that AI could be, maybe scary, or they were not convinced that they could just integrate new technologies in their workflows. But the reality is that the people who used DPCB and maybe other AI tools are seeing that they're much more productive, because if you go back to the example that took 2 weeks that was solved in like a day or two, then it means that within a month, instead of doing 2 designs, you can do 4, 5, 6, 7, 8, So this is the main piece of feedback that we had. People have been asking for extra features, so very technical things in electronic design, like how you exit a pin or how you place specific vias and so on. These are some things that we're listening to and that we're trying to implement, and hopefully some new exciting features will be at DAC in June and at PCB West in September, October.
Okay. I know InstaDeep has deep roots in AI innovation. How does your approach to EDA differ from traditional tools?
So the way we do it is we're not trying to have a given strategy that is human-made for, let's say, the routing. We're not going to say, okay, I'm going to write a rule that is take all of these pins here that have to be connected to those there, and I'm just going to do some shortest path. This is something that works for simple boards, but if you go to something which is bigger, more dense, etc., the shortest path is simply not going to work. You have to do something which is end-to-end, kind of like, I don't want to say AI, but at least end-to-end optimization that looks at the problem maybe more holistically, and that understands the trade-offs of deciding for one net to do a shortest path and then for another one to do something else, right? So this is the way we see it. And then someone could say, so why don't you use optimization solvers? Because if you cannot use heuristics because they're rule-based and they're suboptimal, they're fast, why don't you use optimization solvers? The problem with the optimization solvers is that when you have a big problem, rerunning the solver with just a constraint change or replacing a pin, etc., is going to start from scratch and it's going to take the time that it took to get to the first solution. So each time you're going to change and try something else, you're going to redo the entire thing. The goal with applying machine learning and artificial intelligence in general is to have a system that leverages the past experience, that learns with time, and when you need to change something, you have a neural network which is very fast at inference and giving you new solutions. That's it.
And what is next for InstaDeep in EDA?
I think that's a good question. It depends on the opportunities. Right now, we're scaling DeepPCB, making it much better. Always trying to expand the user base, having more features. We recently added the differential pairs, impedance matching, and so on. But there are so many other things we could be doing. and then tackling boards that are maybe not like 1 or 2,000 connections, but maybe 10,000, 20,000, and go from 6 to 8 layers right now to 64. And then maybe we'll solve PCB design, at least PCB layout, and you have other things needed, like FPGA, ASIC, etc. Right? This is pretty open. We're just focusing on DeepPCB right now, making it the best we can, getting as much feedback as we can from people, and we're pretty confident that this is gonna set us to put us on a path to success.
Okay. Any plans to move into chip level design or system level modeling in 2025 or 2026?
That would be a bit early for us. We're focusing on DeepPCB right now. There are also lots of things happening at InstaDeep, the company in general. So for electronics, we'll stick with DeepPCB for now. Yeah.
Okay. And what is the best way for our audience to find out more about DeepPCB and InstaDeep on the internet?
Yeah, you can find us on LinkedIn. So we have InstaDeep, and we have a new dedicated page for DeepPCB. On our website, which is www.deeppcb.ai, we now have blog posts with basically everything we're doing, be it announcements, new features, the conferences we're going to. And we started being active on Twitter. I mean, it's called X right now, so it's just at DeepPCB as a handle, and you can see everything we're doing. And if you have any questions, of course, we have the usual email, hello@deeppcb.ai.
Okay.
We're reachable at 24/7.
Okay, great. Well, thank you so much, Alain-Sam, for taking time to record this interview. Have a great day and stay safe.
Thank you. Bye-bye. Have a good day.
Okay, this is Sanjay Gangal.
Bye-bye.